All right, what's up, guys? I'm gonna just like get you started on this problem here. I don't, want to work the whole solution out for you, but I've been getting lots of questions about this, so I figure I can give you a little bit of guidance here. Maybe just like help you get the problem set up. So I'll, use my numbers. Well, I'm not gonna really use the numbers. You guys know I hate numbers, but let me write down the symbols I'm using so everybody understands what I'm trying to say. Okay, so we have to be a little careful here. We're given lots of things. Lots of like lengths and stuff, right? So let's see. Let's call the height of the top of the meter stick, let's call that just h with no subscript. Right, so this is, for me, it's going to be 2.07 meters. Let's call this time interval, let's call this time interval delta t. This is 0.266 seconds. We're also going to need something that they don't like explicitly tell us, which is the length of the meter stick, but obviously a meter stick is a meter long, right? So let's put that in there. We'll call it L. Okay, so how do we do this is a question that I'm not even really sure of the answer yet, but we'll figure it out. Okay, so it takes some amount of time to pass the length of a meter stick. All right, so what I should do is I should say we have three different velocities here, right? So everybody understands my notation. The first is the velocity with which it is dropped from h0, right? And we'll just say this is v naught equals 0, okay? And I mean, you're not explicitly told this either, right? But it's kind of the only thing we can assume. It says an acorn falls from somewhere higher up in the tree, so I don't know, maybe it has some initial x velocity or whatever, but we don't care about that. We're just going to assume that it falls from rest, right? So let's see here, and I'll try to make this stuff more explicit, like when I write problems for you guys to do on exams and quizzes, but I don't write these problems. Let's see here. Okay, so we have that. Then we'll say the velocity the acorn has when it hits the top of the meter stick, and I mean, this is, the verbiage here is not the best because it doesn't actually like hit the meter stick, but I think everybody understands what I'm saying, right? Or maybe say the velocity the acorn has when it is at the top point of the meter stick. This is a little better, right? We'll say this is v1, and the velocity the acorn has when it is at the bottom point of the meter stick is v2. Okay. So now you know what I mean when I say, v naught, v1, v2. All right, so what I think we want to do here is we want to apply this equation, which is going to be, because we're told kind of what's happening between v1 and v2, right? Because we know how long it takes to traverse the length of the meter stick, and we know how far it goes, right? Obviously a meter. And I'm going to be a little fast and loose with the signs here. I know that this actually might be still pretty confusing for lots of people, but you should be more careful than I'm being, or more sort of thorough than I'm being, because everything I'm doing is correct, right? But I'm not really going to talk too much about why it works, even though it might look weird, if that makes sense. Okay, so anyway, I think what we want to do is we want to use this equation. This is the general form of the equation. gt squared. Okay, this is what I'm kind of thinking about here. Now, what I am saying is that we said that the length of the meter stick is L, okay? And this equals the initial velocity or speed that the Acorn has when it's at the top of the meter stick, v1t, v1, let's say, oops, v1 delta t, right, to be as consistent as I can with my notation. And then I'm going to put a plus sign here, and this is probably what might mess people up. I'm going to put a plus sign here. I'm going to say plus 1/2 g delta t squared. Now, I'm doing this because when the Acorn hits the top of the meter stick, its velocity vector is pointing in the same direction as its acceleration vector, right? Its velocity vector is pointing down, and its acceleration vector is just the g vector that also points down, right? So if I wanted to be maybe a little more careful, I would wind up with this expression, except there's a minus sign in front of every term. But you know, I can always just look at that equation and multiply both sides by -1, and nothing about the mathematical truth of that equation changes, right? And it's just a little nicer and easier to work with. So that's sort of what I'm doing here, but you should, you know, try this for yourself and make sure you can convince yourself that this is okay, I guess. Okay, so we have everything here. Except for v1, right? v1 is what we don't know, but we could solve for v1 if we needed to. But let's just hold off on this equation, and I'll just put in words here. Let's see. For when the Acorn travels the distance of the meter stick, just so this is hopefully clear to everybody. And so we could solve this for the initial velocity, right? We could get v1 out of this because we know L, we know g, and we know delta t, right? So I'm going to say that v1 is in principle known. Now, the other thing is to then maybe apply this equation, and I'm just going to write the general form, as I always do, which is that v squared equals v naught squared, and yeah, I'm gonna be I'm gonna be a little, well, maybe I shouldn't. Maybe I should do this correctly because I think people are probably still confused about this. So let me write this the way that I would do it if I wanted to be very thorough and pedantic. So I know I'm kind of mixing approaches here, but hopefully this is better than me just not doing any of this. Okay, so this is the general form of the equation that I want to use, right? So what I'm trying to do with this is I'm trying to figure out how far it falls from when it is at the top of the tree, with v naught being 0, and when it's at the top of the meter stick. Because we know now, I said in principle, we know the speed or the velocity it has when it hits the top of the meter stick. So if we can just figure out how far it has to travel in the vertical direction to get that speed, then we're pretty much good to go, okay? So this is the general form of the equation I'm using. Now I'm going to plug it in to match what I've written, and that is this. That is v1. Okay, so this v1 is the same as this v1. v1 squared equals v naught squared minus 2g, and we have to be careful here, right? We have to use the correct displacement. Now remember that this delta y in general is y final minus y initial, right? Y final minus y initial, and the final here is going to be h. Let me just make sure this is correct. Yeah, the final here is h, right? Because this is 2.07 meters above the ground. Okay, the final is h, and the initial is h naught. So let's plug that in, right? So I'm going to write h minus h naught. Okay, now let's like just, you know, rewrite this. And what we have here is we have that this v naught squared is just 0, right? Because we are kind of inferring that it starts with no speed or no velocity in the y direction. Okay, so what we have then is this. All right, now on the left hand side I'm squaring something, so that has to be positive, right? And on the right hand side I have negative 2g, obviously negative because I'm saying that g is positive 9.81 meters per second squared. And then we have h minus h naught, right? But h is smaller than h naught, okay? Which means that term inside parentheses is negative. So what I'm doing is I'm multiplying negative 2g by something that will work out to be negative. So it's okay, right? Because I can't have something squared equals a negative. We're not going to, you know, use imaginary numbers or anything like that in this class. Though they are actually pretty useful for physics and engineering, but that's a different discussion. Okay, so I've basically done the problem at this point, right? Because this V1 is the same as this V1. And what you need to do is you need to combine this equation and this equation to get your answer. And your answer is h naught, right? So I'm not going to do that for you because I want to leave something for you to do. And, you know, I hope that everybody kind of just watches this video after having attempted the problem, right? And, you know, struggling with it a little bit because, you know, as I think I've said to many of you at this point, that's really how you learn this stuff, right? You got to fight with it. All right. So yeah, let me know if this is helpful. I can do more little videos like this if there's demand, and, you know, reach out if you have any questions. All right.